The paper discusses the issue of biases in large language models, LLMs, that are inherited from their vast training corpora. Although traditional debiasing methods have been somewhat effective, they do not completely eliminate memorized biases and toxicity in LLMs. The authors propose an unlearning-based approach to debiasing in LLMs by performing gradient ascent on hate speech against minority groups, thereby minimizing the likelihood of biased or toxic content. This technique, called mask language modeling unlearning, selectively forgets and disassociates from biased and harmful content. The remarkable capabilities of LLMs are largely attributed to scaling laws, which suggest their capability heavily depends on the model size and training dataset size. However, training on massive corpora often results in LLMs inadvertently acquiring social biases present in their training datasets. Addressing these biases is crucial for the development of fair and responsible LLMs. The author's study explores an unlearning-based approach that makes LLMs forget biased and toxic content, inspired by the successes of prior work in unlearning privacy-sensitive data. Experimental results demonstrate the effectiveness of this approach in diminishing bias while maintaining language modeling abilities. Surprisingly, the results also unveil an unexpected potential for cross-domain transfer unlearning. Debiasing in one bias form, e.g., gender, may contribute to mitigating others, e.g., race and religion. Counterfactual data augmentation techniques aim to mitigate bias in training datasets by altering bias-associated terms, such as gender pronouns and religious identifiers. However, these methods risk erasing or misrepresenting minority groups. Sentence debias and iterative null-space projection, INLP, adopt sophisticated approaches to identify and neutralize bias at the sentence level. Sentence debias computes sentence embeddings to detect a bias subspace, projects sentences onto the bias subspace, and subtracts this projection from the original embedding to neutralize gender bias. INLP removes specific attributes from representations by training a linear classifier to predict the attribute and then projecting the representations into the null space of the classifier's weight matrix. However, these methods risk removing pertinent information and degrading the model's language modeling abilities. Self-debias, a novel post-hoc strategy, leverages the model's internal knowledge for self-debiasing. It prompts the model to generate both biased and unbiased versions of text, comparing token generation probabilities to distill non-discriminatory outputs. Despite its limitations, SELFDEBIAS highlights the importance of considering the interconnected and multifaceted nature of bias across domains. The authors propose a debiasing technique that demonstrates cross-domain generalizability, offering a promising direction for comprehensive and universal debiasing solutions. They introduce a bias and toxicity unlearning technique, employing gradient ascent to maximize the loss function for specific undesirable patterns in the training data, thereby minimizing the likelihood of such patterns. Masked language modeling, MLM, unlearning selectively unlearns harmful content within the text by forgetting only toxic or biased tokens, while preserving language modeling capabilities. The loss function for MLM unlearning is formulated as equation 1. Where the goal is to minimize the probability of the masked word given the surrounding context. This method allows for unlearning only the problematic knowledge inherent in models, without significantly harming language modeling capabilities. The authors present the experimental setup and evaluation methodology for their proposed MLM unlearning approach to debiasing language models. This method utilizes the dynamically generated hate speech dataset, DGHS, focusing on hate speech against women, to identify toxic words and mask them for unlearning. The experiment employs GPT-4 to identify toxic words and GPT-2 for unlearning, with a batch size of 50 training steps, and a learning rate of 1E5 to minimize the degradation of language modeling performance. The authors evaluate their method using 3 datasets: Wikitext2, Crow-S pairs, and StereoSet. They assess language modeling performance by measuring perplexity on the Wikitext2 dataset. For bias evaluation, they calculate bias scores based on the model's preference for stereotypical over anti-stereotypical sentences on the Crow-S pairs and StereoSet datasets. The results show that the proposed MLM unlearning approach maintains language modeling performance comparable to if not exceeding, that of previous methods, including CDA, sentence DEIAS, INLP, and SELFDEBIAS. The authors highlight the balance achieved between debiasing effectiveness and preservation of language modeling abilities. The bias scores of the proposed method are compared to existing debiasing techniques on the CRO-S pairs and stereo set datasets, demonstrating the efficacy of their approach. Large language models have been shown to perpetuate biases, which can have significant consequences in real-world applications. To mitigate this issue, researchers have developed mask language modeling unlearning, a novel approach that targets the reduction of biases by disconnecting harmful content from specific bias attributes. By applying this technique, the authors demonstrate its effectiveness in debiasing language models without compromising their language modeling capabilities, as evidenced by performance on various benchmarks. Notably, their findings suggest that debiasing in one domain, such as gender, can inadvertently lead to debiasing in other domains, like race and religion, a phenomenon referred to as transfer unlearning. This transfer unlearning phenomenon has significant implications for the development of more equitable language models. While the study presents promising results, its limitations are discussed in detail in Section A, highlighting areas for future improvement and refinement. I'm happy to help. However, it seems that there is no content provided for me to refine. Please provide the transcript you would like me to refine, and I'll be happy to assist you in creating a concise, technically accurate summary of the research paper. The application of GPT-4 focuses on identifying and masking bias-related keywords, emphasizing the need for explicit mask rules to enhance reproducibility. The concept of invalid unlearning, particularly with the GPT-2 model, highlights the challenge of ignoring words following masked tokens. The appendix includes examples from datasets like CRO-S pairs and stereo set, demonstrating the context of stereotypical and anti-stereotypical statements. Perplexity results across different unlearning steps are presented, showcasing the model's language modeling performance and its effectiveness in reducing bias without compromising overall performance.